start, first of all, to thank our friends and Andre and Ilya for these very interesting topics and for coming here from St. Petersburg to join us this evening. I would like to talk this evening about artificial intelligence in test automation. I hope that you know at least something about artificial intelligence, at least some popular topics from the news. Just a few words about me. I'm active member of QA Serbia, software quality assurance engineer, and with expertise in building testing frameworks. So if you are not following us on Meetup or you're not following us on Facebook, start doing that.
Or Instagram.
Yeah, or Instagram, yeah.
On demand.
So we also have a dedicated Slack channel where we answer your questions all day long, especially interesting ones. So this is a short overview of topics which will be presented tonight. So what is artificial intelligence? Which steps we have to do to start creating machine learning system for automated testing? A little bit about how to actually test systems which contain artificial intelligence. Then how to do test suite reduction, how to do test case prioritization, and to discuss a little bit about 5 levels of autonomy and comparison with self-driven cars or self-driven vehicles. So let's start with a small definition. Maybe not the best one, this is from Wikipedia, so probably there are better ones, but basically machine learning and machine intelligence is of course different than intelligence in human beings or animals. So these kind of intelligence are coming naturally, at least to some people. In computer science, defined as intelligent agents. So any device which can perceive its environment and take actions is thought to be intelligent. So where it can be applied? So currently there is a really big movement and I would say lots of investment in artificial intelligence. We can see that many big companies are investing there. So currently, one of the topics is this self-driving car. Maybe you follow the news, but a few months ago, the first was in San Francisco, and on the first day it got a crash. It got crashed while the people were inside, and actually, one of the truck drivers didn't follow traffic rules, and the car crashed into the truck. But anyway, there are still, of course, huge progress in this area, and much progress will follow. So basically, we can split artificial intelligence in 2 groups. One is general artificial intelligence, and the other is machine learning. For us today, for test automation, machine learning is the most interesting, and the steps which we have to take to create a system which will execute and create test cases are based on machine learning. General artificial intelligence is basically there to develop systems which are self-aware, like some kind of robots, systems which can communicate to human, so these kind of things. For testing, we're going to focus on machine learning. So what is needed to start with machine learning and how to train the system for testing and for test automation. So the problem is, and the problem which we have to solve with the help of machine learning, is that we have to create a system which executes tests on the application and verifies the correctness of behavior of that application. So the steps which we can take are that we should train our learning system, our machine learning system about the application. Then we should train our machine learning system about interaction with the application, and to train this system how to verify the results. So, okay, this is the same. So, just a short overview. So basically, I don't know, probably most of you are here testers, or at least you're testing your code, even if you are developers, you're using some unit testing. Sometimes you're doing manual testing. You want to basically be sure that your application works before you continue, or it is your everyday job. So basically every tester is in a loop that basically starts with the deployment of a new code, then there is testing, some bugs pop up, then these bugs are fixed, and then again this code is deployed, and we are doing this repeatedly every day. In some companies they put focus on manual testing, some companies are more focused on automated testing, but basically this is some kind of loop in which we are involved every day. This, of course, means huge effort from people who are doing manual testing or people who are automating test cases, especially in a world of enterprise applications, which are extremely big. Changes can bring lots of risk of breaking on some parts completely not which at the first glance are not connected to this change which we are implementing, but somehow there are some subtle ways to break application on some other side. So basically in machine learning we are implementing a similar approach which we are doing as manual testers. So basically we have some test input, we put that test input to be used by our function or by our application, and we have some output and we verify that output. The result can be bug or correct behavior. So for the machine learning system, the approach is, as I said, similar. So we have to train our system to use the inputs, and then we check whether the output of this training set is what we are actually expecting. So just about today we will not discuss about the inner side of machine learning system. That can be based on artificial neural networks, convolutional neural networks, state vector machines, decision trees, or whatever you decide to use as a machine learning system. So let's discuss a little bit how to start with this. So the first step is basically to train your application about the state of the application. How we are doing that? So the idea is to take a screenshot of your application. So this basically means that this is mostly focused on UI applications, so graphical user interface applications, but this can be also done if you are using API. So some kind of saving some kind of a state. So for this, we are using an approach called labeling, and basically, currently this is done by human being. So we have a screenshot in like a pixels image, and we also are saving a document object model which presents this picture. So both of them are coming together, and then some tester or whoever, I don't know how we can call that person, who is giving the labels, is deciding about the category to which this page or this screenshot belongs. So this can be, for example, home page, login screen. In our case, this will be other, and then it will add a new category, which will be contact page. So this is the first step. So after the first step, we are starting to train our machine learning system. So this is the first step to train it. And so what we are expecting here? So we are putting here all these labeled screenshots, but without label. And we want to see as the output, we want to see this label that basically machine learning system made the decision to which category this screenshot belongs. If everything was correct, then basically we are done and we don't have to continue training our machine learning system. If not, then we have to make changes in our algorithm and make some improvements, or make it better or worse, it depends, of course. But still, the goal is to have the best result. So what is actually the best result? So basically, the ideal result is something, analysis of the result can be done by something what is called confusion matrix. And as you can see here, on this diagonal are actually the values and how our machine learning system decided whether it was successful or not. So if it was a home page, whether it is decided that it is actually home page, or it is decided it's maybe contact or registration page. So of course there are some errors, and the goal is to have all zeros below and above the diagonal. Of course, this will be ideal system, but we cannot expect that kind of behavior. So we should basically decide when to stop. So some kind of error will be always present, but if that doesn't impact us too much, we can basically survive with that kind of error. So now we trained our application about the state. So now we have to train our machine learning system about what kind of actions a system can make on a certain page, or better to say, on elements of the page. So one of the let's say first challenges which we should give to our machine learning system is to make difference between button and text box. So nowadays, of course, there are different styles and different designs of web pages, and sometimes you just cannot differentiate whether it is a text box with a text. Okay, as a human being, you can easily do that, but for a machine, it would be difficult, especially with these flat designs, so almost no difference. Anyway, so we are now training. The goal is to train a machine learning system what actions can be taken on the elements of the page. And some advanced learning would be to actually make some complex actions. For example, to search for something, to buy something, to change profile picture, to I don't know, do whatever is a sequence of actions, not just one simple clicking or writing the text. And after we trained all this, we have to train our machine learning system to make decision whether this behavior, which is expressed by application, whether it is a bug or it is some acceptable behavior. For this, we can use 3 different approaches, and probably will in our when we are working with the development of this kind of system, probably we are going to use all 3 of them. First one is checking for common issues. So this is mainly, you can say that we are doing that now as a part of test automation. So we are checking the logs, whether something happened on a user side, on a server side, whether we have some unexpected exceptions and these kind of things. So this is something what we train our machine learning system, what kind of errors are acceptable and what kind of errors are not acceptable, at least just to basically monitor for these kind of things. Second approach is to actually train for the bugs. And this is really difficult because it is difficult to create a database of bugs. So if we have some bugs which are already fixed, then we cannot do too much about that. So we'll have like to go back in our code and maybe reproduce these bugs, save screenshots, and apply these kind of things to machine learning system to just give it examples from which machine learning system can learn to be trained what is a bug and what is not a bug. And at this moment, the final stage, final step is that we give a human being possibility to verify the flow. This is really important if we have changes in a system. So, and we created such a machine learning system which will not create a bug if he notice that there is some new functionality, but you never know whether that new functionality is actually newly development or it is because of some side effect or something like that. So as a last step, we can give that to human to verify that, okay, this is really a new implementation and it behaves correctly, or it is really a bug and application shouldn't be in that state. Sorry. So just a short overview of these steps. So basically, this is all what is needed. All these steps, they are of course complex, but these are the starting points from where you can start building machine learning system for executing automated test cases. So just overview of this, what we should do. So screenshots with a DOM, which are actually categorized. So put the labels on every screenshot. Then start training your system to decide about these categories, to which category that belongs. So for example, okay, I started with the pages, but that can be also web elements. As I said, we can train the system to recognize text boxes, links, buttons, images. So whatever can be found on a page. Then train your system to make interaction with the pages. So how that can be accomplished. So if it is text box, maybe it cannot, okay, left click, does it make sense? Well, maybe, but not too much. But then if you have a right click, well, maybe that can bring some dialogue, especially in desktop applications, something like that. So if you're on mobile, it's tapping instead of clicking. So basically training your machine learning system how to interact with that application. And then train your system to make verdict whether some behavior is actually acceptable or not. So after you do all these steps, hopefully you'll have a system which can execute autonomously at least most of the test cases for the application for which you are actually creating this machine learning system, and hopefully for the similar applications as well. So the goal is to have like one machine learning system which can cover all similar applications, not just as one product from one vendor, from one company, but also from many other with different designs, with different layouts, so that machine learning system is able to recognize, not regardless of what is on the what is the company behind this web page, but to recognize the state in which this application is and what actions it should take to make some goals, like for example searching or buying or something like that. I hope that this sounds okay. And now this topic is really important, not just for the people who are going to develop machine learning systems, but also for people, probably testers who are wondering how we can actually test this kind of systems. So code coverage doesn't work here. Unit tests, okay, you can have them, but does it make sense? Well, maybe to some degree, but mostly not. So there is no UI, so does it make sense to have some API or something? Well, maybe, but that's not the point of this. So machine learning systems contain lots of nodes which make some decisions, and basically, can you know why some node made a certain decision at a certain point? So these are the techniques which we can start testing artificial intelligence products. So the first is something what is called feature computation. So basically, when we are training our machine learning systems and when we are basically giving information to machine learning system, it is usual, and basically this is like a rule, that all information are normalized. This means that basically all information which are coming inside are in a float values, so float numbers between 0 and 1. So one of the approaches to test machine to actually question whether a our machine learning system is working correctly is this feature computation. So this feature computation is this is example when we have lots of text boxes, and basically we sit and we analyze our application and we say, okay, maximal number of text boxes on one page can be 100. If if on the page we have 10 text boxes, then the value which will be passed as a value for text boxes will be 10 divided by 100, that is 0.1. So the problem here, which can have a big impact on the machine learning system, is that if we make bad choice about maximal number. So if we, for example, go with 50, and we have pages with more than 50, then basically in some cases we were going to miss some information. If we go with a too big number, for example, if we actually can have 100, but we go with a number, maximum number of 1000, so in that case, these values between .01 and 1 are not used at all. And that is not good for a machine learning system, because this loses information in this area which is actually not used. Next one is sampling quality. So we decide about training our system, and we are using some screenshots, and we think, okay, these screenshots are coming from some live applications, and everything looks okay. But then, as you can see here, we are training for arrows which are left and right, but then in the real world, all of a sudden we have some arrows which are up and down, and that is what we can expect. I mean, people who are testing every day application, they know how many bugs they find only because somebody design didn't predict some values, some exceptional values, special characters, and whatever can be given to application to process. So this is the case here is the same. So one of the ways to basically question whether our machine learning system is good enough is to do analysis of training data, whether this sampling quality is good or bad. If it is bad, then basically our machine learning system will make bad decision, or its behavior will be really poor. Next one is something what is called outlier tolerance. So in a situation where we have our machine learning system, where we say, okay, our system is completely trained, we went through all three steps, so the labeling is working fine, actions are working fine, verification part working perfectly, we always catching bugs and these kind of things. So then, in order to question how good is our machine learning system, we should give something what is completely different than what is actually expected, what our machine learning system is expecting to get. So, as you can see, this okay, this is not too much interesting example, but you get the picture. So you are training with some arrows, but then all of a sudden you put something completely. And this is the technique. I think it's common for, let's say, normal testing. But this should be also used for machine learning systems. If your machine learning system can handle this kind of inputs, great, then you build a really robust system. If not, then probably you should go back and check your algorithms for labeling, for actions, and for verification. Next one is called labeling quality. So basically, if you see some screenshot, okay, you can decide, okay, this is I don't know, this is homepage, okay, but what about registration page or contact page? Or there are some overlapping between the pages. So sometimes we should be a little bit flexible regarding categories. So some pages in some situation can mean one thing, but almost the same or pretty similar page can mean something else in some other situation. So this example here is not related to pages, but basically if we see something like this on a web page, so we can think, okay, this is a disk, but this can be also magnetic disk, it can be a database, or this can be a file. So of course it depends on the context where it is. So this labeling quality is really important, because with the wrong labels, this first step, which is actually training for examining labels or categories, basically will fail. So next one is a little bit tricky, and it's called quality drift. So let's say that we have something what our application can make our machine learning system, after executing test cases, is making some kind of score, and let's say that this score can be between 0 and 100. 100 is maximum, and 0 is of course the worst, or probably there is no machine learning system at all. So we present our application, and our machine learning system gets score which is 70. So regardless of what does it mean actually, the score, and what is the meaning of this score. So we just invent some kind of scoring method, how we're gonna measure this kind of things. And so basically we have a current application, we run machine learning system, it scores 70. So then there are some changes, and these changes happen, and after the changes are finished, we again process with this application with machine learning system, and it executes test cases, and again the machine learning system gets score 70. So what's the catch? Whether it is the same, or it is similar, or it is better, or it is worse, we actually don't know that. So the focus should be actually on a subset of a testing input. So basically we get just all picture. With that one number we get whole picture, but we don't know what this picture is consisted of. So these parts are really important, because machine learning system can start behaving poorly in some areas, and can have some better performance in other areas. So it's the focus should be on subsystems or subsets, not on a whole set. This is the reason why it is called quality drift. The quality drifts from one area to another, and at the end, as a result, you have the same score as previously, but actually some subsets are behaving poorly. And the final is traceability. So this is really big problem, and there is no obvious solution for traceability. So basically we can do logging, do some kind of debugging or something, but still this just doesn't give us enough information about what is happening in a machine learning system, because there are hundreds, maybe thousands of nodes. And it's really difficult to examine why some node made some decision this way or that way. So for this traceability, probably there will be some time when this problem is at least become more obvious, or the problem of traceability is solved in some kind of way. So basically, here is the list of all testing techniques which can be applied to products which contain machine learning. So from this point, you can basically do Googling, do searching, and you can basically, if you decide to join some company who has machine learning system, you can start applying these techniques to machine learning. So far, we covered machine learning systems for executing automated tests, and we covered how to test artificial intelligence based systems. So now, just a few words about test suite reduction and test case prioritization. So basically, all of us who are doing manual testing or automated testing are always faced with time constraints, and we are always questioned whether we really have to execute that test case, whether it will give some value to our test suite or not. So basically there is a whole mathematics behind this who is dealing with this kind of problem, and the problem is that we want minimal time, we want all features to be covered, we want test cases with a bigger priority to be executed. And for that we want to have optimal reduced test suite. So basically I will not go too deep into this, but I will just say one of the methods is actually one algorithm called multi-criteria test suite reduction. And I think on the next slide we have actually this is something completely new. This algorithm is from University of California. You can find on this link, you can find this article, scientific article, which is explaining how to use that algorithm in order to reduce test suite. The biggest change in this approach is actually switching from linear programming to non-linear programming. So the problem is that, okay, we have a test suite which contains test cases from T1 to Tn. Then we have some constraints which are, for example, statement coverage, or it can be something else. Then we have some optimizations. Optimizations are in a way that we want to maximize fault coverage. And then we need some algorithm which will actually provide us test suite which satisfies all these conditions, and which is actually subset of original test suite. So basically the idea behind this is to have basically starts with linear programming, which means that we have some kind of summation between test cases, multiplied by constraints and optimizations. But then we are switching from, these authors actually switched from this linear to non-linear, which actually means that they are now multiplying criteria and optimization and test cases. And at the end, with some really complex mathematics, they are getting a test suite which is actually minimal test suite which covers these constraints and optimizations. So if you want to read more about that, this is where you can find the article. About just a few words about test case prioritization. Again, this is a subject of mathematics, more or less. So scientists are working on that. This is again a really important topic. So how to decide about priorities of our test cases. So adapt testing to focus more on error-prone parts. then to adapt testing to adapt testing to execution environment. So we have different environments so that these test cases adapt to that environment. Then using reinforcement learning, basically machine learning, to prioritize test case execution. And in this case, there are two approaches: this test case metadata and reward-based functions. Reward functions based on a verdict. This second approach is basically means that we reward machine learning system every time when it did something good. So this is that approach to reward function based on the verdict. So also I believe that you faced you're facing this kind of a problem, how to prioritize your test cases during daily routine. So basically this is the last topic from this I would say technical section, and I don't know, maybe later you can ask questions. So this is more like a philosophical approach or how we are currently standing. So these are the levels of autonomous driving system and how it can be compared with the testing systems. So level 0, of course, is the driver is doing absolutely everything. So what we are currently doing, at least people who are driving. And people who are testing, so manual, exploratory, and regression testing. So no automation, no help. So level 1 is that there is some kind of help from a machine. On a car, this is some functions are controlled by driver, but there are some functions which are controlled by machine. Comparing to testing, this is basically creation of test automation scripts, and these scripts can have some kind of basic self-healing attributes. So this is level 1. Level 2 would be again more advanced, of course. In comparison to driving, automated testing in this level is that actually we have automated, semi-intelligent exploration applications and without human intervention. Then level 3. Humans here are just to describe high-level intent. It was already mentioned that, for example, add something in a basket, or buy something, or delete something, or do something with the system. So these kind of high-level intent, and then automated system actually decides how to accomplish this. So this is on level 3. In level 4, for testing, machine generates and executes most of the coverage across exploration and regression testing efforts. So basically, you just give it to machine learning system to do exploration and to do regression testing. Okay, human will maybe decide about some parts, but still, this is one of the ideals and the goals. So in this level 4, it's minimal intervention from a person. And on a level 5, this is like ultimate goal or holy grail of not just for testing, but also for other aspects of everyday life, is to have a completely autonomous machine learning system who can make decisions, give feedback, give statistics, whatever is needed for further analysis. And of course to make a decision whether there should be a release or no release based on the test results after the test execution. So what will the future bring? Of course nobody knows that, but at least we can make some assumptions regarding these kind of things. So it's evident that there are more and more companies who are investing in test automation and test automation based on machine learning systems, and companies who are actually doing that in some good or bad way, but still they are struggling to make this machine learning system as good as possible. So should you actually care about that? Well, I think yes. First of all, even if machine learning system starts to occupy testing area, there should be still a possibility to test these machine learning systems. How far we are from completely autonomous systems? Well, I would say not that far. With such big investments and huge progress in mathematics and such a big hype in machine learning, definitely in a couple of years these kind of systems will be introduced to many applications. So basically this is the end of my presentation. I hope that you have some questions or anything. Just a small reminder, QA Serbia is giving away a t-shirt for everybody who asks a question regarding this topic or previous topics. So, no, you can only answer.
There is artificial intelligence in testing. Is there artificial intelligence in software development?
That's not the subject of my interest, so I don't know about that area. I see some movements there. I see that, for example, there are some tools which can be used as extensions for certain integrated development environments, basically which are going over Stack Overflow and taking some code from there and trying to, implement these from these answers which are highly remarked to implement these kind of approaches. But I really don't know about software. Oh, you can. Okay.
I think I can. So I was also involved not on this project, but some others about machine learning. So I think the ideological answer is no, and so why? So the answer is that development is about creating something new, and artificial intelligence is about learning how to do the same as some other guys did. So, for example, how categorization works. You will get some data to learn the system. After that, you can produce something new. And development is about producing exactly something new just from what you have. So the answer is no, just because development is something new, and if you need some machine learning in development, that means you are doing something like copy pasting. And in development, this is not a good way of creating something new. Yes.
Isn't it mostly
yeah. Of course it is. Yeah. Can I answer the question?
Okay.
Which algorithm of machine learning do you use in your testing application?
I'm not going into that area. This is still like a subject.
You use some algorithm?
Well,
It's time for questions. Very funny story. It does take some time. So, as I said, we had e-commerce misses, and it was a very funny problem. We have a lot of data, and for example, just imagine a shop, online shop, and you can choose, for example, color. I need red dress, and it should be derived by red. But unfortunately, this data came from humans, and they always do some mistakes. So the problem was how to test categorization of a product. If this dress is really red, and here we had why we just not choose a main color of the picture to check what happens. It will work for dress, but it won't work for example, bras, because they are dressed on a model, and model has different color, and most of the picture is model, not what they are tested. We really implemented a machine learning algorithm neural networks. Actually, we tested with the Google services because they provided some resources to run these algorithms. Because actually, the problem is these engines that requires a lot of resources, huge amount, so we succeeded to implement algorithm with categorization check. So it was related even about shoes, it was related to clothes and so on, and it really helped to check categorization. We found a lot of mistakes, so yeah.